How's it going, everyone? This video is about how to visualize the size of the Earth. Okay, so someone might tell you that, well, the radius of the Earth is just over 6,000 kilometers, or almost 4,000 miles, right? You might hear the diameter is almost 13,000 kilometers, or almost 8,000 miles, right? But how do you visualize that? How do you imagine, okay, how big is that really? Okay, you want to be able to compare it to something that you can feel, okay? So that's what we're going to talk about, okay? So let's start with the diameter, okay? So if you were to drill a tunnel through the center of the Earth, okay, so you start on one end of the Earth, you dig all the way to the center, and then you just keep digging all the way up to the other side of the Earth. So the length of that tunnel would be 12.7 thousand, so almost 13,000 kilometers, or almost 8,000 miles. So what if you had to drive through that tunnel? Okay, well, if you're driving at 100 kilometers an hour on average, or 62, 63 miles an hour, then it would take you just over 127 hours to drive through that tunnel that goes right through the center of the Earth and end up on the other side. Okay, so 127 hours of driving. Well, what is that? Well, if you're driving all day, 24 hours a day, let's say there's 4 of you in the car, you're taking turns driving, eating, sleeping, the car never stops, it'll take you just over 5 days. Let's say it's a more leisurely drive, on average 5 hours a day. So you drive some, you get out, walk around, sightseeing around underground, right? So on average 5 hours a day you're driving. It'll take you 25 and a half days, so almost a month, to drive in that tunnel right through the center of the Earth and out the other side. Which seems like, oh yeah, it's not that long, right? Just 5 days of full driving, just under a month of leisurely driving gets you all the way through the center of the Earth. Now let's talk about circumference. Okay, so the path around the Earth. Now, when we say going around the Earth, what exactly do you mean, right? Because if you're at the North Pole, you can just take a short stroll, just a few meters long, around the North Pole and say, oh, I'm walking around the Earth. So what we mean here is the widest distance around the Earth. So around the equator, for example. Okay, so if you're standing anywhere on the Earth and you were to draw a circle that goes around the Earth, and the circle passes where you're standing, and the center of that circle is the center of the Earth, that's the kind of circular path we're talking about. Okay, so the circumference of that circle, the circumference of the Earth, easy to remember, it's about 40,000 kilometers, or 25,000 miles. Okay, now when we're talking about distances this huge, it's okay to be approximate, right? 40,000 kilometers plus or minus a few kilometers doesn't really matter. Okay, so it's a little bit longer than 40,000 kilometers. It's still approximately 40,000. The same with the radius, the diameter. These distances are approximate and average because the Earth is not a perfect sphere. Okay, the distance from the surface of the Earth to the center is a little bit different in different parts of the Earth. So these are average approximate values. So what if you had to drive all the way around the Earth? Let's say there's this circular road, or on a spherical surface that would appear as a straight line, that goes in a circle around the Earth. So either a road along the equator, or another circular path around the circumference of the Earth, like along a line of longitude, for example. So that would take you approximately 400 hours. Again, we're driving 100 kilometers an hour, or 62 and a half miles an hour. So 400 hours. So if you're doing straight driving, okay, the car never stops, you got 4 people, you're taking turns driving, eating, sleeping, it would take you 17 days to go around the circumference of the Earth. 17 full days. If you're taking a more leisurely drive, right, driving about 5 hours a day, we're talking 80 days. So just over 2.5 months, just under 3 months, which actually seems pretty reasonable. Like, it's not that long to go around the entire Earth if there was such a circular road like that, right? So we're talking, you have to drive around the oceans and all that, or along the ocean. So these are all length scales, okay? So the radius, diameter, circumference, right? These are all measures of length. Now let's talk about surface area. Okay, let's say we wanted to paint the entire Earth, like oceans, ground, everything, right? We want to, and we're not talking about like caves and mountains, just there is a sphere the size of the Earth, and we want to paint that entire sphere, okay? How much paint would we need to paint the entire Earth? Well, the surface area of the Earth, it's approximately 510 million square kilometers. Okay, that's a big number, doesn't really tell you much, right? So if we have to paint it, how much paint is that? So if a gallon of paint, okay, I'm approximating that a gallon of paint can cover about 400 square feet, right? So, and a gallon of paint, that's a typical paint can, okay? So it's not the small ones, it's not the huge ones. It's typical, you imagine a paint can for painting like ceilings or walls. It's a gallon of paint. So you would need approximately 14 trillion gallons of paint in order to paint Earth's entire surface area of 510 million. Okay, 14 trillion gallons of paint. So how much is that? 14 trillion. Well, if we take the world population, which is about 8 billion people, okay, and we divide that by 4, okay, then we get approximately the number of families there are on the planet. Okay, if you approximate on average 4 people per family, Earth's population, divide by 4, you get the number of families, and then multiply that by 7,500. Why 7,500? So 7,500 is approximately how much grains of rice there are in a cup of rice. We're talking about uncooked rice. Okay, turns out there's a whole debate about how to calculate this, how to estimate it. There's some interesting math that gets into it, but that's not the subject of this video. We're just going to go with that number, 7,500 grains of rice, of uncooked rice in a cup of rice. So if every family in the world is going to hold a cup of uncooked rice, okay, and we're going to count all those grains of rice, that number of grains, that is how many gallons of paint. That's how many paint cans we're going to need. Okay, so imagine you're standing there with your family, you've got a cup of rice, it's uncooked rice, you're going to count the number of grains in that cup. And that number of grains, that's how many paint cans you have to buy. Now, that's a lot of paint cans, it's expensive, it's going to take up a lot of room, but you can imagine doing that. Okay, so if every single family did that, we would have enough paint to paint the entire surface of the Earth, including the oceans. Okay, land, oceans, the whole surface. So that is how big the surface area of the Earth is. Now let's talk about finally volume. Okay, the volume of the Earth. How much space is there inside? How much stuff could fit inside the Earth? Inside the space that the Earth takes up. That is approximately 1 trillion kilometers cubed. 1 trillion cubic kilometers. Okay, so, again, huge number. How do we imagine that? Well, first let's figure out, well, what is a cubic kilometer? Just 1 cubic kilometer. So if you imagine just a length of 1 kilometer, now imagine a cube, which has a side length of 1 kilometer, that's a cubic kilometer. Okay, that's kind of imaginable. Let's get a little bit more specific, okay? We're going to work with the world population again of being 8 billion approximately. So a typical can, like a garbage can, outdoor garbage can, not the small ones that go in your kitchen, but like the big outdoor ones in the park or what you put outside for when it's garbage day, right? It's approximately 125 liters. So 125 liters times 8 billion, okay? That is 1 trillion liters. And 1 trillion liters is 1 cubic kilometer. Okay, so if every single person in the world filled up one of those outdoor garbage cans, the amount of garbage that would take up, the amount of space that all that garbage would take up is 1 cubic kilometer, which seems like, well, that's not that much, right? That's not that much. So we are going to need 1 trillion of those. Okay, so all that garbage from 1 can per person in the world, okay, that is just 1 cubic kilometer. We need 1 trillion of those. Okay, so how are we going to imagine that, right? Let's say we're gonna bury all our garbage underground, right? We're gonna fill the earth with garbage. How can we imagine how much space there is in the earth? Okay, 1 trillion of that amount of garbage. Okay, let's imagine something smaller. Okay, so instead of 1 trillion, let's take 1% of that. 1% of a trillion is 10 billion. Okay, so we're just going to fill up 1% of the earth with garbage. Okay, so 10 billion cubic kilometers. So let's take this number, 1% of a trillion, 10 billion, and we're going to divide it by 52 because there's 52 weeks in a year, and that gives us about 200 million. All right. So if every person in the world produces one of these outdoor garbage cans worth of garbage, okay, every week. Now you have to be very inefficient to do that, right? So like no recycling, no reusing anything, no compost, so just everything you're not using anymore, you're throwing it out. Okay, then yeah, maybe each week you'll generate one of these garbage cans full of garbage. So every person in the world generates one of those garbage cans full of garbage each week. Okay, then it'll take us approximately 200 million years to have enough garbage to fill up 1% of the Earth's volume. Okay, so what was 200 million years ago? Well, that was the dinosaurs, like real big dinosaurs, not birds, like actual dinosaurs, right? What people think when they hear dinosaurs. So if at the time of the dinosaurs, there were as many people as there are in the world today. And since then, every single year, there have been that many people. And every week since then, every single person has been generating an outdoor garbage can full of garbage. And then by today, we will have filled up 1% of the Earth. Okay, so there's this computer loading screen showing how much percent of the Earth have we filled with garbage so far, right? Starting from the time of the dinosaurs, 8 billion people on the Earth every day since then. Every week, every one of them creates a garbage can full of garbage, outdoor garbage can. By today, we will have gotten to 1% on the loading screen, 1% of the Earth full of garbage, right? So the Earth is huge, right? It's huge. It's a massive, massive amount of volume, right? Another way to think of it is, well, 10 billion is it's approximately 8 billion, right? The 10, 8, the numbers are pretty close, right? So imagine every person on Earth, okay, has to fill up one of these garbage cans for every single person on Earth. Okay, so you need to fill up a garbage can for everybody on the planet and give it to them. And of course, you are also receiving a garbage can from every single person on the planet because they are filling it up for every single person on the planet too. Okay, so then you'll have almost 10 billion cubic kilometers of garbage, and you will be almost at 1% of the Earth's volume full of garbage. So the Earth is huge. So hopefully that helps you visualize that. We talked about length scales, diameter, radius, circumference, right? The driving durations we talked about for diameter, just divide that by 2 to get the driving durations to get just to the center of the Earth from the surface. We talked about surface area, painting it. We talked about volume. Okay, how much garbage would we need to fill up even just 1% of the Earth's volume, how long that would take. And hopefully that helps you visualize the size of the Earth. And I'll see you next time.